Chapter 4-5. In this chapter, we're going to look at 3 more shortcuts to proving triangles are congruent. The first one is angle, side angle. So the side is included between the 2 sets of congruent angles. So far we have side, 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 which is proving all 3 sets of corresponding sides are congruent. We have side, angle, side, which is proving 2 sets of corresponding sides congruent and the angle included between the 2 sides. And we have now angle, side angle, where the side is included between the 2 sets of angles that we are proving congruent. We will also have angle, angle, side, and we will have HL. The first step in any proof is to write the given down, draw a diagram if they don't have a diagram, and then mark what you know on the diagram. So let's go ahead and write the given. L is the midpoint of WE, and WR is parallel to ED. And that information is given to us. So we know that WR is parallel to ED, and we know that L is the midpoint of WE. If L is the midpoint of WE, we then know that WL is congruent to EL. And that's by the midpoint theorem. We also know that the vertical angles are always congruent. So we know that angle WLR is congruent to angle ELD, and that's because vertical angles are congruent. Now we have the angles, we have a side that's attached to those angles. To have angle, side angle, we need to show that this angle is congruent to this angle. So angle W is congruent to angle E. Well, we know that WR is parallel to ED, so we also know then that angle W is congruent to angle E because they're alternate interior angles. So parallel lines give us alternate interior angles congruent. So now we have angle, side angle, and triangle WRL is congruent to triangle EDL, and that's by angle, side angle. In this next fill in the blank proof, we're given that AB is parallel to CD, and that AD is also, we have that AB is parallel to CD and AD parallel to CB. And we want to prove the 2 triangles are congruent. We have or know that angle ABD is congruent to angle CDB, because AB is parallel to CD and we have alternate interior angles. They share a common side, which is BD, so we know that BD is congruent to DB because of the reflexive property. Then because BC is parallel to AD, we also have another set of alternate interior angles. So we have that ADB and CDB are congruent. So now again we have angle, side angle. The next one we're going to look at is angle, angle, side, where the side's not included between the 2 angles. To complete this proof, sometimes it's easier if you separate the two triangles that we're looking at. So it's easier to mark what you know. So we have triangle JMN and triangle LK. See if I can write this a little plainer, a little clearer. So we have the two triangles, and we have J, M, and N, L, N, and K. We write our given first at angle NKL. So NKL is congruent to angle NJM. So those two angles are congruent. We have that KL is congruent to JM. So KL is congruent to JM, and this is our given. Now, if we look at the two triangles, they both share this same angle right here. So since they share this same angle, by reflexive property, it's congruent. So angle N is congruent to angle N, and that is by reflexive. So now we do have angle, angle, side. So triangle JMN is congruent to triangle KLN, and that's by angle, angle, side. And then we can conclude that segment LN is congruent to segment MN. This was not mentioned in the proof itself, but is something that since the triangles are congruent, we know all the corresponding parts are congruent. So corresponding parts of congruent triangles are congruent, CPCTC. Okay, so to complete the next proof, we'll separate the triangles again so it's easier to see what we have. So we have D, A, B, and E, A, C. We're given that angle ADB is congruent to angle ACE. So ADB is congruent to ACE. We're also given that EC is congruent to BD. So EC is congruent to DB, and this is our given. We know that they share a common angle, which is angle A. So angle A is congruent to angle A. Reflexive. Oops, that was a really bad reflexive. So we have triangle ADB is congruent to triangle ACE. And that's by angle, angle, side. Then we have angle AEC is congruent to angle ABD by CPCTC. Corresponding parts of congruent triangles are congruent. So we've covered side, 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 angle, side, angle, side, angle, and angle, angle, side. And we have a couple special cases that I want to look at. And there's these 4 theorems, but you don't have to memorize 3 of them. Because in a right triangle, this one is just side, angle, side. This one is angle, angle, side. And this one is angle, side, angle. So the only one that we have to think about is HL. And for HL, we basically look at it. We have angle, side, side, which I have said you can never use angle, side, side except for a special case, and that is in a right triangle. So if it is a right triangle, and you can show that the hypotenuse is congruent, the corresponding hypotenuse are congruent, and one of the legs is congruent, then we can say the triangles are congruent by HL. You cannot put ASS, but you can put HL. So we want to determine whether each pair of triangles is congruent. So for this one, we have the right angles are congruent. So this is congruent to this. We're given that another corresponding pair of angles are congruent. And we're giving that the side between the 2 angles are congruent. So yes, this is congruent by angle, side, angle. If the triangles are marked to the vertexes, then I could ask you to do a congruent statement. This one has all 3 sets of angles congruent. But is this a valid congruent statement? To look at it, what if I drew triangles like this? And I told you that this was parallel to this. Then we know that by corresponding angles, those would be congruent. We also would know that these are congruent because of corresponding angles. And if I then separated the 2 triangles, oops. I know that the very top angle is a shared angle here, so it has to be congruent. So I have angle, 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 all 3 sets of corresponding angles congruent, but the triangles are definitely not congruent. So this angle, angle, angle does not work, so this is no. On the next picture, the 2 triangles share a side, which is this side, which is actually the hypotenuse of both of the triangles. The legs are congruent, or one pair of corresponding set of legs is congruent, and they are right triangles. So this is yes by HL. So let's do one last proof. Again, let's separate the 2 triangles so we can clearly see what we're working with. We have A, C, and B. We have B, D, and C. We're given that AB is perpendicular to BC, and that DC is perpendicular to BC, and that AC is congruent to BD. So let's mark the one that AC is congruent to BD. Now we have 2 sets of perpendicular segments, and those 2 sets of perpendicular segments tell us that ABC is a right angle, so angle ABC, and that is because AB is perpendicular to BC. DC is perpendicular to BC, so that tells us that angle DCB is also a right angle. And this is by definition a perpendicular. We also notice that they both share a common side, which is BC. They both have BC here, so we can say that BC is congruent to BC, and that's by reflexive. So we have the hypotenuse, the corresponding hypotenuse congruent. We have a corresponding leg congruent, and they're both right triangles. So we can conclude that triangle ABC is congruent to triangle DCB, and that's by HL. And we can finish our proof by concluding that DC is congruent to AB, and that's because corresponding parts of congruent triangles are congruent. And that concludes our lesson.